Okay, hello, grade 11s from Nelson High School. Mr. Kendall here. Let's take up a bit more of the homework from Thursday, October 4th. We were doing word problems using quadratics. And this is from your textbook, page 130, number 18. So grab your textbooks, page 130, number 18. And it's a measurement question. So the length of a rectangle is 2 meters more than the width. And then the area of the rectangle they give is 20 meters squared. And they're going to want the dimensions of the rectangle. So they're going to want the length and the width of the rectangle. And they want that to the nearest tenth of a meter. Okay. So we've got ourselves a measurement question dealing with a rectangle. And when it comes to a rectangle, you should know how to calculate its area in terms of its length and its width. And to do that, I think it always helps, and I highly recommend you first draw a diagram here. So draw yourself a rectangle. And label the key dimensions. So we've got length, width, and then in here there's a given area to this rectangle. Okay? You should know by heart by now that the area of a rectangle is length times width. Okay? Now with these word problems, you want to define variables. You want to be able to tell us what your variables mean with respect to the given problem. So in this problem, it look like this. We're going to let L be the length, W be width, and A the area of the rectangle. Okay. Let's take a look at the word problem now and try and extract some information to help us, because all we have now is an area, length times width. Okay, so let's reread. It says the length of a rectangle is 2 meters more than the width. So L is 2 more than W. Well, mathematically then, if L here has 2 more units than W, so L, he's got 2 more than W. Well, if we give an extra 2 to W then, so add 2 to it, then they'd be the same. So really you can say that the length is equal to W plus 2. And now for your length here, you could add it to your diagram. This is actually W plus 2. And we do this because when we make our quadratic, we're only going to make it with 2 variables. Remember, a quadratic is usually y equals x squared and some other stuff in x. Well, here we're going to make a quadratic, and it's going to be in terms of area, and we're going to only use 1 variable. So it'll now look like this. The area is equal to length times width. The area is now only going to be written in terms of width, and so then we replace this length with W plus 2 times W. Okay? Let's expand here by distributing. And here is W squared plus 2W. Okay, this is great. We've got a quadratic. Our y value is A and our x value is W, the width of a rectangle. And now we go back to our problem. It says the area of the rectangle is 20 meters squared. So we're going to replace the area here with 20. But W squared is 2W. And we're going to send everything over one side. Perfect. A nice quadratic in descending order degree, W squared plus 2W minus 20. Okay. This is the step where you use the tools you have. We've developed some tools in this course. You have to choose which one to use. So we learned how to complete the square, we learned how to partial factor, we learned how to factor and we know how to use the quadratic formula. For this question, since we have to solve this for the w that satisfies this equation, it only makes sense to either factor or to use the quadratic formula. You would only partial factor or complete the square if you wanted to find a maximum or a minimum, which is a vertex of the quadratic. That's not what we want to do here. We want to solve this, so we can either factor this and find the solutions, or we can use the quadratic formula. And if you take a close look at this, factoring is not going to really work, because you got to find two numbers that multiply to give minus 20 and add to 2, and you're going to be dealing with decimal numbers. So I'd recommend using the quadratic formula here. So if we're going to use the quadratic, first off, what are our a values? Okay, our ABC values from a standard quadratic. Now, standard quadratic would have the form ax squared plus bx plus c, right? And I mean, in this case, we're using w for a variable. But nonetheless, you should be able to see that here a is just 1, there's a 1 in front of the w squared, b is 2, there's a 2 in front of the w, and c, make sure you carry the sign here, is minus 20. Okay, quadratic formula now. Remember, in terms of w is the variable. So, w is minus b plus or minus b squared minus 4ac over 2a. Okay, your goal now is to take your ABC values, put it into the quadratic formula, and solve for the solutions of w. Remember, you can either have one solution, two solutions, or no solutions. So what I'd like everyone to do is work out the width, and I'll give you guys, I'll pause for a sec and give you guys a chance to do that and be right back. Okay, so we're back. Hopefully you've come up with the following two solutions. If you work out the width, this quadratic formula, the solutions are w is 3.6 and w is minus 5.6. And in the question, they wanted to the nearest tenth of a meter, so that's why there's only one decimal place, the 0.6, and here the 0.6 as well. Now, okay, think about this. You've got this rectangle length and width, and you're presented with two possible solutions. Well, you can only take one of them here, and it's pretty obvious that you can't have a negative width. So this solution here, the negative one, makes no sense. So we say that a solution that makes no sense, can't have a negative width, is what we call inadmissible. So you write inadmissible. Okay, as w has to be greater than 0. Width has to be greater than 0. Okay? So you have to go with this answer. The width is going to be 3.6. What we'll then say is the following. Our length from earlier we defined as w plus 2. So our length is 3.6 plus 2. Okay, so the length is 5.6. Now, one key thing here, when you're done these questions, you need to answer it with a sentence, and you need to answer the question properly, using the right language, and also using units. So the question would answer like this. The dimensions of the rectangle are 3.6 meters by 5.6 meters. Now you could tell us what length and width are as well, but dimensions are usually given something by something. Either way is fine. You could have said something like the dimensions of the rectangle are, the width is 3.6 meters and the length is 5.6 meters. As long as you've got units and it's clear and answers the question, you'll be fine. Okay, so I'm going to take up question 29 now from page 131. So please find that in your textbook. So in question 29 here on page 131, it says the function h is equal to minus 5t squared plus 20t plus 2 gives the approximate height h, it's in meters, of a thrown football, and it has a function of time, which we're using t in seconds, and that's since it was thrown. And the ball hit the ground before a receiver could get near it. So now in part A, how long was the ball in the air? It's the nearest tenth of a second. And B, for how many seconds was the height of the ball? At least 17 meters. Okay, so we're dealing with a quadratic function, and we've got height of a football versus time. And they're asking us a few questions here. So the first thing you're going to do is recognize this as a physics question. And with these physics questions, really any word problem from quadratics, you're going to want to draw a diagram. So I've started a diagram, and it looks like this. Okay? So I've got my y-axis and my x-axis, and for this application question, y is actually h for height in meters, and x is t for time in seconds. Okay? We've got a little football player here. He's thrown a football, and at some point it landed, and I believe, unfortunately, the receiver missed it, so an incomplete pass here. Okay, so there's your diagram. It's not to scale, but it does show, and when we're done, it does show key points from this quadratic. All right, so let's talk about this. Okay, first off, the equation here, h is equal to minus 5t squared plus 20t plus 2. It gives us some information already. Okay, this negative sign means a is less than 0, and it opens down, opens up, I apologize. No, I'm confusing this. It does open down, and I'm thinking up because it's a max. Okay, this is a maximum type graph. It opens down, and at the top there's a maximum. Okay? Some maximum right here. Also, from this equation, you can tell what the y-intercept would be. Okay, our y for this question is h, and if you set t equal to 0, put a 0 in for t, put a 0 in for t, all that goes away, and you're left with, at the value of t equals 0, h is 2. So 2 is our y-intercept. Okay? So if we come back to our graph, remember at t equals 0, h is 2. That's our y-intercept. And the y for this question is actually height, h. Okay. So now, in the question, it says, how long was the ball in the air to the nearest tenth of a second? Well, our little player here shot the ball, and it went up to a max height, and it came down, and it landed right here. So how long was the ball in the air? Well, it started in the air. You know what, guys? He's 2 meters tall. That's exactly what this means. At a height for y, and with a y-intercept of 2, this football player is 2 meters high, so he launches it from his height of 2 meters, just over 6 feet, and throws it across the field. It's incomplete. It lands over here, and this is how long it was in the air, from here all the way to here. Okay? So this point right here crosses the t-axis, and if you could imagine over here, this parabola, the path of the football, would cross the time axis over here, but over here that would be negative time, and that just doesn't make sense. So when we do our solutions to a quadratic formula, we'll get two solutions. We'll get this solution as an x-intercept, or as a root, and we'll get this solution as an x-intercept. And only one of them will matter because, well, this one's negative and negative time doesn't make sense, and the other one will be positive. So basically, if you want to figure out how long, in part A, the ball was actually in the air, you need to solve this quadratic, okay? And to solve this quadratic, you have to solve it for when the height is 0, because at this point, the ball was thrown. It starts at 2 meters, gets thrown, goes up some height, comes down, hits the ground. Well, at the ground, the height is 0. So that's what's key. At the ground, h is equal to 0 meters. Okay? So all you need to do for part A is say at h equals 0, determine t. Okay, so think about how we're going to do that for a sec. Okay, hopefully you paused to reflect for a quick second there. So at h equals 0, we have to determine t. Well, what we need to do is use this quadratic they gave us, set h to 0, and solve for t. So let's do that. So h is equal to minus 5t squared plus 20t plus 2. Set h to 0. And we end up with a quadratic we need to solve. To solve a quadratic, we talked about a couple methods. We said we could factor this, or we could use the quadratic formula. And in this case, I'm going to choose to use the quadratic formula because there's no two numbers I can find that are whole to do this with factoring, and it would end up being a complex trinomial. So the easier choice, I would say, is to use the quadratic formula. So first step for the quadratic formula is we have to determine the a, b, c values that go into it. And for this particular quadratic, a here is the value in front of the t squared, so it's minus 5. B would be 20, the value in front of the t variable, and then c is 2. Okay? In this case, this quadratic has a variable of t, so we use t for time as opposed to x. Remember, in this question, our x variable is time and our y variable is height. So writing out the quadratic formula. Again, guys, you're going to want to know that by heart. So we're going to substitute a, b, and c into there. Please take a moment to try that. Remember, with a quadratic formula, you will get 0 solutions, 1 solution, or 2 solutions. And what I pointed to earlier, here's our quadratic. The football player is 2 meters tall. That's the y-intercept, launches the football, and it lands. Well, right here, that's one of the solutions. And over here, that's another solution. Okay? When you solve, you're solving for where h equals 0, which is exactly what we've set up So you're expecting 2 solutions. So give that a shot, and I'll be right back with you. Okay, so we're back. I hope you took the time to try and solve this quadratic formula by yourself. I've shown all the steps, and I arrive at 2 answers, 2 solutions, as expected. One time is minus 0.098, okay? And I mean those are seconds. The other time is 4.1 seconds. And as I said earlier, okay, when you're looking at this quadratic, the football's path, this time here, which doesn't make sense, is minus 0.98 seconds. And then this time here, where it lands, where the player missed it, is 4.1 seconds. Okay, so this answer, in terms of the physics, you can't have negative time, so this answer here is inadmissible. You can't have negative time. The answer we want is the following. Okay, it makes sense. Just throw a football, you know, within about 2, 3, 4, 5 seconds, you're going to catch it, or it's going to hit the ground. Just any NFL, CFL game, that's what you'll see. So that makes complete sense. So the time in question A, how long was the ball in the air? Okay, you could say the ball was in the air for 4.1 seconds. Okay, so take a minute to reread question B, and we'll get set up for it. So in question 29, the path of a football, part B, they want to now know for how many seconds was the height of the ball at least 17 meters. So the height of the ball, h, equals 17 meters. What you need to do here is you take 17 meters, the height of the ball, and replace it for h. And when you do that, you'll end up with 17 equals minus 5t squared plus 20t plus 2. You have a quadratic. You then just use your simplification methods and solve it for time. Okay, now let's talk about that graphically. Okay, so again back to our sketch of the parabola. So we don't know what the max height is, it doesn't matter. It's some value TH. Okay. They want to know at 17 meters, okay, how long was the ball above that? Well, imagine 17 meters occurs right about here. So then, graphically, you can see here, it would be these points here. So at least 17 meters is when the ball is in this range. So it occurs at this time here, and it stops occurring at this time here. So whenever you replace 17 for h and solve this quadratic, the 2 solutions you're going to get out of that quadratic are these 2 times. Okay? The time where it began, a height of 17 meters, and then it continues over 17 meters, and then the time where it ends being 17 meters. So let's set up our quadratic with h equals 17 and solve it. Okay, so I've set this up at h equals 17 meters, we want to solve our quadratic. So we replace 17 for h, and we're going to solve this. So as you can see, I've started here, 17, I need to send over still to this side, so it's 2 minus 17, so 0 minus 5t squared. Minus 15, okay. What I'm going to do, I'm going to divide everywhere by minus 5. I can do that. I can divide every term by minus 5. 0 divided by minus 5 is 0. Here I get t squared minus 4t plus 3. And okay, this looks like our quadratic in standard form. Standard form would be like an ax squared plus bx plus c. So you see that, then you're like a is 1, b is minus 4, c is 3, and you're thinking to use the quadratic formula. That's right, that will work. But also another tool to solve equations is factoring. So if we want to factor t squared minus 4t plus 3, we need a number that is a product, two numbers that are a product to give 3 and a sum to give minus 4. And in fact, those numbers are the following. Think about it. Two numbers that multiply to give 3 and add to give minus 4. Well, those numbers are minus 1 and minus 3. So instead of using the quadratic formula, I can say t minus 1, t minus 3. And then we can break that into our parts. So that would be t minus 1 equals 0, t minus 3 equals 0. And solving that, t would have to equal 1, t would have to equal 3. Okay, and there you go. We've got 2 times. We expected 2 times because earlier when I showed you this diagram, we said the ball's thrown, it lands. They asked us when it's 17 or higher, give us the time range. And we drew some points, and we realized that this point and this point was the range, and now we've just solved it. This is 1, and this is 3. So the question can be answered now in part B. For how many seconds was the height of the ball at least 17 meters? Well, that occurred between 1 second and 3 seconds. And, well, last time I checked, 3 minus 1 is 2. So the answer is it occurred for 2 seconds. Okay? So for 2 seconds, that's 3 minus 1 equal 2 seconds. The ball was at least 17 meters. Okay, be sure to end with a sentence. This makes sense. Again, looking at the diagram, at 17 meters, everything above that, it occurs between 1 and 3. The solutions to solving this quadratic here when h is 17. Okay, I do want to show you another tool that can help you guys, and I've already done some examples in class, but let's just show you. So probably want to open up another tab or internet browser so you can follow along for this part. So let me just set up right with you. Okay, it just took a sec to set up here. So this question gave us a quadratic with h for height and t for time. And let's analyze this using some online tools that can help us. So we're going to go to Wolfram Alpha, and we're going to enter h is equal to minus 5t squared plus 20t plus 2. Alright, that's our equation. And why don't we first plot that? Plot, which would mean graph. Let's see what that does. So we get a nice quadratic curve. In fact, you can see this point here, which we said was the negative time, which was the solution at h equals 0, and then about 4.1. You can see it there as well. That's just a parabola. Okay, how about instead we say the following. Let's find the max. Let's just see how high the ball goes. Okay, so it's giving you the answer here. The max occurs when h equals 22 at t equals 2. So at 2 seconds, the football was at a max height. And what about Let's try solve h equals 17. Okay, so it's solved this, and it's found two solutions, t equals 1 and t equals 3, which we found earlier. So it solved this for 2 points, and we can tell that it's actually occurring between time equal 1 second and 3 seconds, which we found earlier. Another thing you can do is we use the quadratic formula in this question, right? We used it whenever we found our solutions in part A and in part B. Let's just go back to part B here. We found that the answers to this quadratic were 1 and 3. Well, let's actually put these numbers into a quadratic solver online. So online, if you Google quadratic formula solver, pick one, and then you take your quadratic formula. In our case, it was minus 5t squared plus 20t plus 2. We solved for height of 17. It reworked itself into the following quadratic, and we said the a values, b values, and c values, they would have been 1, minus 4, and 3. So let's put 1, minus 4, and 3 in for a, b, and c. 1, minus 4, 3, and solve that. And you can see here that the solutions are 3 and 1, so you're able to check that. Okay, even going back to the question in part A, we solved the following quadratic. This is where the height was 0, and we had a, b, and c values of minus 5, 20, and 2. That would look like this. So minus 5, 20, and 2, and we'll solve that, and we get our negative time and our positive time. Okay, so these are great tools. Try stuff out with Wolfram Alpha. It's very convenient to check your answers and add reassurance and help visualize things because they make great graphs. Okay, don't shortchange yourself. Make sure you know how to do this on your own with the skills we talked about in class. And thanks again for listening. Mr. Kimball here, and take care.